Hi, thanks for playing this video. What we're going to learn to do here is we're going to translate our written statements into an algebraic equation or vice versa. And right now we're going to start out by looking at just some written sentences and their algebraic expression. Friendly reminder that an expression like these things right here do not have an equal sign, and eventually our goal is to be able to translate into algebraic equations where we do see an equal sign, okay? We're going to start out here though with just expressions to just kind of review some of the basics of some of the words that can be used to represent an expression. So for example, when we see the 2x, over here, this is written right now, it's an algebraic expression, it's in the language of algebra, and we want to know how to translate it into a written sentence into English. So for this, we have lots of different options, and if you guys want to take notes now with how we can say this right here, the first way we can say it is saying the product of a number and 2. The product of a number and 2. Friendly reminder that when we write a product with a coefficient, the coefficient always comes first. So this is the product of a number and 2. It is also twice a number. If you see the words twice a number, that's a 2x. And if you see 2 times a number, that's a really elementary school way of saying it. So this top one up here and the middle one, these are kind of more advanced ways of saying it. And then the last one's kind of elementary where it's like 2 times a number. All right. Friendly reminder again, we use something called a coefficient to show multiplication. We are no longer seeing like x times 2. We certainly don't see like x times 2. If we want to show this, we're just doing a 2x at this point, okay? All right, cool. Now let's focus on the here x over 2, the fraction thing. So we've got a few ways here that we can say this. The quotient of a number and 2. So quotient is the answer to a division problem. And this right here is showing to divide x by 2. So the quotient of a number and 2 looks like this. X divided by 2 looks like this. And half a number looks like this. If we take half of a number, a lot of us think that when we're taking half of a number that it looks like this, and this is true. That is how you can show half a number. But dividing it by 2 is also technically half, so it's a synonym. These are synonyms, if you will, and I'll type that word out that I'm saying, the English word, synonym. We're saying the same thing. Half a number is the same thing as x divided by 2. All right, let's move on now to some plus stuff. All right, so when we see x plus 2, of course we know that that's a really elementary way of saying it, x plus 2. But now the more algebraic ways of saying it are the sum of a number and 2. So sum, we're adding things up. Up top, we talked about product. We've already reviewed the word quotient, and now here we see the word sum. All right, we could also say that this is 2 being added to a number, 2 added to a number. We could say it's a number increased by 2, so x, a number, gets increased by 2. Or we could simply say 2 more than a number, 2 more than a number. If we have 2 more than a number, it's x plus 2. All right, so there's 4 ways in purple of saying that. And now last but not least, let's talk about the subtraction stuff. So when we see this right here, it is 2 less than a number. If up top is 2 more than a number, this is 2 less than a number. So there it is in green, 2 less than a number. The difference of a number and 2, difference is the answer to a subtraction problem. So the difference of a number and 2 is x minus 2. A number decreased by 2 is, of course, x minus 2. Up here, this is a number increased. This is a number decreased. And, of course, elementary style, x minus 2. That's the old school way of saying this, just x minus 2. Now, before we do anything down below, I want to point out a really common mistake, and it's this thing right here. A lot of times when students translate 2 less than a number, they see the word 2, then they see the less, so they think that they're supposed to put the minus and then an x, okay? This is incorrect. 2 less than a number means that the number comes first. Now show me 2 less than that by taking away 2. So we're going to talk about this word than. We're going to talk about that down below here in a second. So I just wanted to point out right here, this is wrong. This is wrong over here. This is a very common mistake. All right, cool. So now let's practice translating these written statements into an algebraic equation. Remember the topic up above, we're going to translate the written statements into an algebraic equation. And I think to start out, it's easier to see the algebraic expressions and then how we might say it in English. So now we're going to see it in English and we're going to translate it over here into algebra. Now, because we're dealing with equations at this point, our first step, y'all, we're going to look for the word is because that's going to tell us the equal sign part of this, which makes it the equation. So for the first one here, we have 7 less than the product of -5 and c is 3. So I see right here the is 3. So I'm going to go ahead and circle that away and translate the is 3 part. So we've taken care of step 1. We circled the is and we translated it. All right, so now we're going to go for the than. 7 less than the product. So I'm going to box the than. Now I'm going to translate from left to right here after the than. The product of -5 and c, so the product of -5 and c, now show me 7 less than that. So again, 7 less than the product of -5 and c, we should see 7 less than this product of -5 and c. Off to the side, I'm going to show you in purple the really common mistake that I see. I see people doing 7, then they see the word less and they think that they're supposed to be taking away, and then they do the product of -5c. This is wrong. The than, when we box it, this helps us catch it when that is the step that we take, y'all. This helps us catch that everything after the than, this part really comes first. Now show me 7 less than that by taking away 7. We are now done. We have translated this. We have 7 less than the product of -5 and c is 3. All right, now let's look at the next one. 4 more than twice a is 16. So we have the is 16. So I've got is 16. There is the word than, so I'm going to box the than. And now twice a, that comes first. Twice a looks like this. And now show me 4 more than that by adding 4. We have translated this is now 4 more than twice a is 16. All right, for the next one. The product of r and 6 decreased by 7 is 35. So here's the is 35. Now for this problem, y'all, there is no word than. So we're able to skip step 2 and literally just translate from left to right. Now the product of r and 6, remember we don't want to show r and then a 6. The coefficient always comes first. So here's the product of 6 and r. Now we're going to decrease that by 7, so -7. We've just translated this is the product of r and 6. Decreased by 7 is 35. All right, for the next one, 9 times a number is equal to 3 times the sum of a number and 1. There's a lot going on here. I see the word is. 9 times a number is equal to. All right, so 9 times a number is equal to. So we have here 9 times a number is equal to. Now on the other side, it says 3 times the sum of a number and 1. Now we haven't seen something like this yet. So if we're going to be multiplying 3 times a sum, we got to put the sum in parentheses. And I know this is kind of hard to read because I have that picture in the background. But if it's going to be 3 times the sum, here's 3 times, and then the sum is the answer to an addition problem in these parentheses. So the sum of a number and 1, we're going to put in here. Here's a number plus 1. So now we've translated here, we've got the sum of a number and 1, 3 times that answer, and that's what we have over here on this side in red. So 9 times a number, so 9x, is equal to 3 times the sum, so 3 times, and then the sum has to go in parentheses. And you might remember from PEMDAS that anything that happens in parentheses goes first. So if we have 3 times the sum of a number and 1, the sum of the number and 1 happens first, and then 3 times that answer is on the outside. Okay? All right, let me see if I can move that over just a little bit. There we go. All right, cool. Now we're on the next one that starts with 11. Okay, y'all? So 11 is the same as 5 less than 4 times a number. 11 is, there's the is, 11 is the same as. So for this one, I'm going to write it over here. We're going to start with 11 is the same as. Now we're going to do 5 less than 4 times a number. I have the word than. So 4 times a number needs to come first. 4 times a number, so 4x. Now show me 5 less than that by taking away 5. So 11 is the same as 5 less than 4 times a number. All right, we're about halfway through with our translating examples. Now for the next one, we see the word quotient. The quotient, it should say of a number h. So the quotient of a number h plus 10 and 5 is negative 4. Okay, so the quotient of a number and h, and I think actually, y'all, I'm reading this one. I want to get rid of the and 5. This is my mistake. Let's scratch this out. Okay. All right, so the quotient of a number and h, so the quotient of a number and h, now plus 10, is negative 4. This right here, you guys can see, has 2 variables in it. We are not doing anything this school year where we're trying to solve with 2 variables. Next school year, you guys will learn how to solve equations that have more than 1 letter. But for right now, we can see here we have the quotient. And like I said, this should say of a number and h. So the quotient of a number and h, now plus 10, is negative 4. All right, now we've got 12 decreased by the quotient of a number and negative 3 results in 6. Now notice for step 1, we're looking for the word is. We actually don't see the word is here. But having results in 6, that's the equal sign for this problem, okay? So for this one, just because of space, I'm going to translate it down here. So it results in 6, so we have an equal 6. Now, I don't see the word than anywhere, so we're just going to translate from left to right. 12 gets decreased by something, so here's the 12 being decreased by. It gets decreased by the quotient of a number and negative 3. So it's getting decreased by the answer of this division problem, a number and negative 3. So this is the equation, 12 being decreased by the quotient of x and negative 3 results in 6. Now, some of you might be looking at it and wondering, if I'm subtracting and there's a negative here, should I worry about rewriting it? Eventually, yes, if I were going to have you solve it. But right now, if we're just translating as is, this is good to go. All right, now we're on the one that begins with the word half. So half the difference, I'm going to write this one down here. Half the difference of a number and 8 is equal to 20. So here's the is equal to 20 part. We got that, is equal to 20. Now when we're doing half the difference, y'all, a lot of us are going to see the word half and think, okay, here's a half. And now half the difference. So difference is the answer to a subtraction problem. So I need parentheses. The difference of a number and 8 looks like x minus 8. So this is one way to write it. We've got half the difference of a number and 8 is equal to 20. Earlier up here, we talked about how half a number is the same as just dividing it by 2. So another way we can write this, y'all, is we can take the difference of x and 8, and when we divide that by 2, that's the same thing as taking half of it. And then we can put the is 20. So both of these, again, work. And I'll copy and paste down here now, this word right here, synonym. These basically are like math algebraic synonyms here in green. They're saying the same thing. All right, we've just got 2 more examples here. All right, for this one, 12 gets increased by 1/3 of k, and that is the same as 9 less than 2/3 of k. All right, so we do have the word is. We have is the same as. All right, there's my blue. Now over here, there's no than. We have 12 increased by 1/3 of k. So 12 plus 1/3 k. So 12 plus 1/3 k is the same as 9 less than 2/3 of k. So we do have a than. The 2/3 of k needs to come first. Now show me 9 less than 2/3 k by minusing 9. So for this one, and I'm going to just fix the 12 plus just because I think it looks a little bit weird. Let me just fix the way I wrote that. Plus sign should look better right here. You'll notice that this equation has variables on both sides, and I am going to be teaching you guys how to solve the equations with the variables on both sides. So I wanted you guys to see how to translate one like this. We also saw one up above where we had a variable on this side and a variable on this side, and I am going to be teaching you guys in another video how to solve when you have variables on both sides. All right, so we just translated that was 12 increased by 1/3 k is the same as in blue, 9 less than 2/3 of k. All right, we're finally on the last one here, and I know my work is kind of all over the place, but I'm on the last one, and I'm going to translate it right here down below it. So we have 4 times the difference of x and 3 is 6 times x. So we have the is 6 times x, so I'm just going to go ahead and put is 6 times x. And now let's look at the other side. There's no than, but we do have 4 times the difference. And anytime we see times the difference, or half the difference, or where was times the sum? Here was times the sum up here. We need parentheses. So times the sum or difference needs parentheses. 4 times the difference of x and 3. So the difference of x and 3 is in here in parentheses. And we have now translated that 4 times the difference of x and 3 is 6 times x. So again, here's another example where we see the variable on both sides, and I will be teaching you guys how to do that. We are done now with this translating video where we're working on how to translate written statements into algebraic equations. Thank you for watching.